Okay, here we go with homework sheet 11. I'm getting a wee bit longer, folks, and a wee bit harder. First question though should be okay for us. Okay, we need to find the gradient perpendicular to this line. So the first stage is to write it as y equals mx add c. And once we've found m, that's going to give us what the perpendicular gradient is. So how are we going to do that for this question? Well, the problem here is the 2. So if I take the 2 over to the other side, I get 3 over 2x plus 5 over 2. That allows me to identify the m, which will then let me get the perpendicular. For the second question, this one is a recurrence relation working backwards. We know the formula, un plus 1 equals 0.2 un add 9. So if I start with what we know, u5 is 0.2 u4 plus 9. Why am I starting with that? I'm starting with that because we know that u5 is equal to 11. So if I substitute this into the formula, I get 11 is 0.2 u4 plus 9. Rearranging, just swap the sides all round about. I get 0.2 of u4 plus 9 is 11. Take the 9 over to the other side, gives me 0.2 of u4 is equal to 2. Make that, oops, that's a bit too small. And then if I take the 0.2 over, I can work out that u4 is 2 divided by 0.2, which you can do as 20 divided by 2, which is 10. So that tells us that u4 is equal to 10. Now if I repeat that whole process again, right, but at this time I have u4 is equal to 0.2 of u3 plus 9, and do this whole blue section again, that should let me work out what u3 is. For question 3, we're used to doing these ones where the lines are collinear or the points are collinear. Okay, so we need to work out first of all what PQ is. PQ is little q minus little p. Right, we can do that from the question. We then need to work out QR. Now the good thing is we don't even have to work it out this time because I've been nice and I've told you that it's 2, negative 4, 6. Okay, and taking 2 out there as a factor gives us 1, negative 2, 3. If you do the same thing up here and then you look at these two answers, then we can work out that PQ is equal to something times QR, and that something is your ratio. For question 4, 2 cos x plus 1 is 0. We can do this, come on, surely we can. Take the 1 over, divide by the 2, cos x is negative a half, do your cast diagram. Right, where is cos negative? And then you can work out what the answer is. Only issue, guys, is remember it is in radians. So transfer to radians. Question 5, we are to work out the coordinates of t using the equation we're given there. So writing it as little t minus little r equals 3 times. Now again, the question tells us what r to s is. It's 2, negative 1, 3. If I take little r over, I've got 3 lots of 2, negative 1, 3 plus whatever r is. Question tells us that. And then we can just write our answer as a set of coordinates. Question 6. Find the value of cos 2x. So I'm going to use the expansion cos squared x minus sin squared x. We have our little triangle for x. Cos is negative 2 over 5. So we can do a little bit of Pythagoras to work out this number here, and then we can start to plug the values in here, square them, do a takeaway, and get our answer. Question 7, solve this equation. Problem here is the power. So how do we get rid of the power? We need to get rid of the e to the power. How do you do that? By taking the natural log off the right hand side. And then you can work out what t is. Question 8. Now question 8 is a bit of a tricky question. Here's the equation of a circle. Now from this equation we can use the negative 12x and the negative 10y to tell us what the centre is. Okay, and I'm going to do that for you because it's not too difficult. Half of negative 12, change the sign. Half of negative 10, change the sign. So our circle is centred here. Okay, the radius is the square root of 6 squared plus 5 squared minus k. And this whole question centres on this fact here, the radius. Where can I draw a circle based on this centre that touches the axis in 3 places? Well, if it just touched that one, it would go down below there, come back up. That's supposed to be a circle. Okay, so the radius would be 6. There is no point making the radius 5 to touch this axis because it doesn't touch the other axis. Therefore, the condition where it just touches that one but goes through there and comes back up, that happens when the radius is 6. So we need to solve 6 squared plus 5 squared minus k is equal to 6. How do we do that? We get rid of the square root. So 36 add 25 minus k equals 36. And if we get rid of the square root, solve that, we're going to get an answer k equals. Okay. However, that's not the only question, the answer to the question. You could have had the situation where the radius went through, or the circle I should say went through the origin, because it would cut it once there, once back up here, round it goes, and then once over here. So here, here, and here would be your 3 points. So what circle has that for a radius? Well, we know that it's 6 along, 5 up to get to the centre. So a wee bit of Pythagoras will tell you that radius. So the other answer is when 6 squared add 5 squared minus k is equal to whatever this answer is that you've just worked out. So whatever the answer is here, put it into this formula and then do the same thing as you did here. As I said, it's quite a tricky question because you need to picture it. Number 9, back to our log stuff. Can't really do an awful lot just now with log to the base 2 of 3x add 7. However, the 3 can be written as 3 log 2 of 2 plus log to the base 2 of x minus 1. Why have I done that? The reason I've done that is because this little 3 is going to jump up here. So I'm going to get log to the base 2 of 2 cubed plus log to the base 2 of x minus 1. Again, why is that important? Because I now have a log add a log. And one of our rules says we can write that as a single log. We know what 2 cubed is. So 8 times x minus 1. Because remember, if we're adding logs, we can simplify that as an add. Now remember, we haven't really done much with the left hand side so far. So log to the base 2 of 3x add 7. Okay, now that I've got log here and I've got log here, they can basically cancel each other out, and I'm going to be left with 3x add 7 equals 8 bracket x take away 1. And I can just solve that as a normal question Okay, I can work out what x is. Okay, question 10. I've done a few of these now. Hopefully we're getting better at these guys. First part says find the altitude through C. So that's a line which goes through C, which is perpendicular to that side. So work out the gradient of AB. Use the points. Find the perpendicular gradient. Turn it upside down and change the sign. And then use y minus b equals mx minus a. And you should get the answer that they give. Of the question, find the equation of the median through B. So that's the line through B that cuts this side in half. So we need the midpoint of AC. Then we need to work out the gradient using that midpoint in B. And then we use y minus b equals mx minus a. And then part C is simultaneous equations. Nearly there. Question 11. First thing it asks us to do is work out f of g of x. So we're putting the g into the f formula. So all of this goes in here for x. So that's 10 plus 1 plus x times 3 minus x plus 2. And you simplify that to get your answer. Remove all the brackets, tidy it up. Should get something like this. You will not get this. Do not copy this down as the answer. Right, it'll be something like this. Now you're asked to complete the square on that. So I'm going to complete the square on mine, and then you can adapt my answer for the question that you've got. First thing I'm going to do is I'm going to rewrite it as minus x squared minus 4x add 5. So just swap it around. Then I'm going to take negative 1 as a common factor. X squared plus 4x plus 5. Then I'm going to rewrite that as x plus 2 squared. Now the bracket is going to give me a plus 2 squared. Plus 2 squared is 4, but because it's got a negative sign there, negative 1 times that 4 is going to be negative 4. How do I get negative 4 up to 5? By adding on 9. And then I'll write it back round the way that we would normally write it. 9 take away x plus 2 squared. So that's my answer. It is not your answer. Yours is a wee bit easier. Part C, we need to know when it cannot be defined. It cannot be defined when the bottom part is equal to 0. Right, and the easy way to do that is just say that happens when x minus 2 squared equals 9, or when x minus 2 equals plus or minus 3. Okay, so that is when x equals, take the 2 over, negative 2 added to 3 is 5, or take the 2 over, negative 3 add 2 is negative 1. Again, these are my answers for my formula, not the answer for the question. You need to do the same thing, the same working for your question. Okay, so put your previous answer equal to 0 and solve it. And that's us. Quite long this week.